2.2.1 Continuous Integration of Purpose and Output. Let's start with a story that almost every engineer recognizes. Imagine a band where guitarists, drummers, and singers all practice separately. Everyone masters their part, but the first full rehearsal turns into chaos. Notes clash, timing falls apart, and suddenly nothing fits together. That is exactly what happens in software when teams work in isolation and only try to merge everything at the end. Continuous integration exists to prevent that moment. Instead of waiting for a painful big merge, developers bring their changes together continuously. They integrate early, often, and automatically. Just like a band that checks harmonies every hour instead of once a month, the system stays in tune. At its core, CI is not about tools or fancy pipelines. Its real purpose is simple. Integrate changes frequently so problems appear while they are still small. Many people misunderstand this. CI is not just running tests, and it is not the same thing as deploying to production. CI stops earlier. Its output is a validated build, ready for the next step, not a live release. This idea comes from extreme programming in the late 1990s, where fast feedback was already recognized as critical. Developers commit code several times a day, replacing risky big bang merges with small, safe steps. When something breaks, it breaks early. When fixing it is cheap and fast. That purpose matters even more today. With AI generating code at high speed, integration problems can grow faster than ever. CI acts as a safety net, validating changes before they pile up and turn into disasters. Placed into the broader DevOps story, CI is the first real automation layer. We talked earlier about fast feedback, shift-left quality, shared ownership, and continuous improvement. None of those ideas work reliably without CI. It is the mechanism that turns individual contributions into a working system. A useful way to think about CI is as a river. In traditional setups, code flows in separate streams and only meets at the very end, where conflicts flood everything. CI turns that into a living river, where small streams merge constantly. Automated builds and tests act like filters, catching debris early. What flows out is clean and predictable. In practice, this means developers commit code frequently to a shared repository, usually on short-lived branches. Each commit triggers an automated process that builds the code, runs tests, and checks basic quality rules. If everything passes, the team gets a green build. If something fails, the feedback is immediate, so fixes happen while the change is still fresh in everyone's mind. The output of continuous integration is tangible. It produces validated artifacts, such as compiled binaries, packages, or container images. Alongside those artifacts come test reports, build logs, and quality metrics. These outputs are not just files, they are trust. They tell the team that the code works together and is safe to move forward. This is why CI scales so well. Large organizations rely on it to keep massive code bases stable, while small teams use the same principles with lightweight tools. The size of the team changes, but the purpose stays the same. Integrate early, detect issues fast, and keep delivery flowing. CI is not isolated from the rest of the pipeline. It feeds directly into continuous delivery and deployment. Without CI, feedback loops slow down, quality shifts too late, and automation loses its reliability. So the key takeaway is simple. Continuous integration exists to merge code early and often, producing validated outputs that build confidence and speed. It turns potential chaos into a steady flow. In interviews, this often comes up. A strong answer focuses on purpose, not tools. CI is about frequent integration with automated validation to detect problems early. Its output is a tested build, ready for delivery. And that is why CI is the foundation of modern software delivery. Now that integration is under control, the next question naturally follows. What happens after we have a validated build? That is where continuous delivery and continuous deployment begin. End of section 2.2.1.